Hi guys, nice to see you again. Welcome to Enzo Science Sharing Time, and let's crack chemistry together. Please subscribe my channel and turn on the notification so you can watch my videos as soon as they are posted. Also, don't forget to leave your comments below and like my video. Before we start today's topic, let's have a quick review for our last lecture. Firstly, we introduced an experiment showing us emission spectra, or line spectra. Then we learned Bohr model. There are 4 basic points constructing this model. Have you remembered all of them? The last point is how to use Bohr model explaining the emission spectra. If you forget above details, then I strongly recommend reviewing my last video. Now let's move on to today's topic. Section 1.6 Electronic Configuration and Shell Model. In this section, we will cover 3 points: ionization energy, electronic configuration in shells, and valence electrons. The first is ionization energy. It is the required energy to remove electrons from an atom. This picture shows how electrons are arranged in a sodium atom. In order to remove one electron, we need to overcome attraction between nucleus and the electron. That's why energy is required. Moreover, electrons in the same electron shell have the same distance from the nucleus. This picture clearly shows this point. And they also have the same energy. Alright, regarding the second point, let's take a look at electronic configuration in shells. It tells us how electrons are arranged around a nucleus. Bohr model is a tool used for showing electronic configuration, and only occupied shells are presented. There are 3 rules when using Bohr diagram. Number 1. Each electron shell's capacity is limited, and the maximum is different from each other. In this table we can see that the first shell can only contain 2 electrons, while the 4th shell can accommodate up to 32 electrons. The lowest shell fills first, this is the second point, until they are full or have 8 electrons. Then the next shell accepts another 2 shell. Then the next shell accepts 2 electrons, before the unfilled shell with 8 electrons continues filling. This rule is actually a bit complicated, so I will show you how to apply it when we solve exercise questions. The third point is the outer shell cannot contain more than 8 electrons. Please remember that you need to follow all of these 3 rules at the same time when arranging electrons in an atom. Now let's move to the third topic, valence electrons. Firstly, valence shell is an atom's outermost shell, and electrons in this shell are valence electrons. For example, in this picture, we see there are 3 electrons in an aluminum atom's valence shell, so it contains 3 valence electrons. I highlight the 3 electrons as yellow and leave the other electrons as red, so you can distinguish them easily. Octet rule is very useful in chemistry. It tells us atoms are always motivated to achieve 8 electrons in their valence shells in order to be stable. And octet rule explains valence electrons' properties, like why sometimes they can be easily removed, and how they evolved in chemical reactions. All good? Now let's have 5 questions for practice. The first question asks the electronic configuration for atoms with 19 electrons. Let's fill electron shells from the lowest. The first shell contains 2 electrons. Then the second one contains 8 electrons. And we allocate another electrons to the third shell for now. Now, because we have 19 electrons in total, currently we only have 1 electron left. According to the rule 2 of Bohr diagram, the last electron should be accepted by the next shell. So there are 4 occupied shells, and this element is potassium. Like what I said, I allocate the last electron to the fourth shell. Question 2 asks the electronic configuration of argon. Similar to question 1, we find out it's 288 and there are 3 occupied shells. Question 3 asks us the Bohr diagram of an atom of titanium. At first, we need to find out the atomic number of titanium from the periodic table, which is 22. Then we allocate electrons into shells as per the second rule of Bohr diagram. 2 for the first shell, 8 for the second shell, another 8 for the third shell. Now we only have 4 electrons left, so we let the fourth shell accept 2 electrons. I highlight them as yellow. And then put the last electrons into the unfilled third shell. Please note that the third shell is not filled. So this Bohr diagram is like what I show here. And there are actually 10 electrons in the third shell. This is what we have for titanium. Question 4 asks what the element is with such electron configuration, which is 2, 8, 6. By adding electrons up, we know this electron has 16 electrons, so its atomic number is 16. As per the periodic table, it is sulfur. Question 5 asks the number of valence electrons for an atom with 34 electrons. To answer this question, we need to find out the electron configuration of this atom. 34 electrons can be arranged according to second rule of Bohr diagram. And in the end, it leaves 6 valence electrons in the fourth shell. From the periodic table, this element is selenium. Great! Flashback time! Today we unlock section 1.6, electronic configuration, and the shell model. We introduced the concept of ionization energy, electronic configuration in shells, and valence electrons. Now we level up to level 7, and there's only a final stage we need to pass before wrapping up this chapter. Specifically, we will know what Schrödinger model means during next lecture. If you have not left your comments, please do so right now to help me make this channel better. Also, feel free to leave your questions and I will answer you. Don't forget to like this video and share it. More importantly, please subscribe my channel and turn on the notification so you can watch my video first time. Goodbye guys, and have a good day!